Hi, I'm Lindsay Bennett, Healthcare Executive. In today's video, I'm going to show you how to calculate the internal rate of return, or IRR, in Excel using a realistic healthcare example. IRR is one of several tools that we use to evaluate and compare capital expenditures. The internal rate of return, or the IRR, is the discount rate that makes the net present value of a project equal to zero. Another way of saying that is, what is the annualized rate of return that a project would need for its future value to completely repay the initial investment? IRR is also really useful for comparing projects of different size and scale. If you watched my video on how to calculate the net present value, then you'll remember that NPV, or net present value, is not so great when you have two different projects of different size and scale, like a $200,000 project versus a $30 million project. That's where the internal rate of return is helpful, because it's giving you a discount rate which you can use to compare projects of different sizes. Now, that said, two projects can have the same internal rate of return, but very different cash contributions. Internal rate of return is best considered in conjunction with the other metrics that we use to evaluate capital expenditures, such as the ROI, the net present value, and the payback period.
In this example, we are looking at a project for AI-assisted coding and charge capture for a large physician group. And in this example, we have modeled out that the initial investment is going to cost $450,000 due to software licenses and implementation costs. And then we have our incremental cash inflows, which are coming from a reduction in denials equal to 1.2% of net revenue, and also from improved charge capture and coding optimization, and also reducing reliance on outsourced coding. So that gives us total cash inflows of $1,340,000 in year 1, year 2, year 3, and so on. Then we have some expenses that are associated with this project, and that is the platform subscription and support costs, which are cash outflows of $270,000 a year. And then in line 20 right here, you see the net of the inflows and outflows for the initial investment and then for each of the 5 years. Down here, we've calculated the net present value as $3,711,927, and the formula is down here on the right, as you can see. So the internal rate of return, like we discussed, is the discount rate that takes your future discounted cash flows and makes the net present value equal to zero. And up here in this example, we had used 9% as the discount rate. So the way that I'm going to calculate my internal rate of return is that I can click on the function box and type in IRR, and I can choose IRR and hit OK. And then what it is asking me for is values. So the values I'm going to give it are everything, including the initial investment and all the years of incremental cash flows here. I'm going to highlight that. So C20 through H20. And then you have this line called guess right here, which is the discount rate that you're guessing. Now, you don't have to put anything there, or you could put the 9% there. So we're just going to skip that and hit OK. And my internal rate of return is 237%. Now, that is super high. So if I saw this result, what would I think? Well, the first thing I would think is this is a really, really attractive internal rate of return. In fact, it is double the initial investment in each of the years. And also it's high because there's a very small upfront cost of $450,000 compared to very high cash flows, even in year 1, of over $1 million. So if I saw this, I'm going to challenge this because this is really high. So usually an internal rate of return that's higher than 100% tells me that there might be something wrong with my assumptions. Now, that may not be true, but I'm going to look at them more critically if I get a really high IRR like this. So some of the things that I might ask is, are these cash flows realistic? Is that denial rate realistic? Are we really going to reduce all those denials with this project? Also, what's the basis for the improved charge capture and the coding optimization? Is that realistic? I'm also going to look at, is this incremental cash flow realistic in year one, or does it take time to build? And is it sustainable across all 5 years, like we have it modeled in this spreadsheet? And then I'm going to check to also make sure that we're not double counting any benefits. But if all those things are true, then this is a very attractive internal rate of return, and we could use it to compare to other projects. Now, if you wanted to test what I told you earlier, when I told you that the internal rate of return is the discount rate that makes all the discounted future cash flows have a net present value of 0, we could test that by taking this IRR number that we came up with here, this 237%, and I'm just adding some decimal points so that I make it very precise. And I could come up here to the discount rate assumption that we originally used, because if this is the discount rate that makes the net present value of these cash flows equal to 0, then we should see this number, the net present value, go to 0. So I'm going to go up here to this discount rate, and I'm going to put in 237.233%. And you can see that this number right here went to -1, so super close to 0. If you found this video helpful, head on down to the description where you'll find the link to join my free mailing list, where you'll get modern, advanced revenue cycle and healthcare finance training and templates delivered right to your inbox, as well as career tips to help you reclaim your path, up your pay, and your presence.